All right, I mentioned in my last video what would happen as far as the switch goes if you took out the delay loops and instead of that you just check to see whether or not this port RG12, this button was pushed down and without the delays, and to see how that would react. So I think that since we have this code up and running here, we might as well actually just show that off and kind of show what that looks like. So I'm just going to remark out the delays here and then run the code. I am running this in debug mode, which I really don't need to, but I'm just, yeah, I just clicked that. So I guess we're running it in debug mode. So so now what I would expect is we still have LED 2 illuminated, so we're still setting that up here, farther up here in the header, right there in main, not the header, in main, we're setting that. And then I expect that since we've taken out these delays, the LED 3 that we have is going to be virtually constantly illuminated as well. Maybe slightly dimmer, because it's going to be illuminated at 50% of the time, even though 50% of the time is a very large amount of time. You're not going to see it flash because it's flashing so fast, but it will not be as bright as it would be if you did not have this in here. And then we have this running, but it's running so many times a second that the button is not going to react. My guess is the button is not going to react quite the way we expect. So I'm going to go ahead and insert a video of this working like this.
All right, so we have the code now running on here with no delays whatsoever. So you can see LED 2 is fully illuminated, the green LED is fully illuminated, and the yellow LED is illuminated, but it's actually illuminated at a 50% duty cycle, so it's quite a bit dimmer than you would expect if it was illuminated 100% of the time. So it's actually flashing, but it's flashing so quickly that our eyes can't perceive it. You would have to hook up an oscilloscope or some similar thing like that in order to actually read the flashing of it and see what speed it's actually flashing at. So if we push the button down, what happens is LED 1 illuminates, and then it will either get brighter like it just did, or it will go off like it just did there. And it's completely random what it will do. As long as you hold it down, it will be at exactly 50% because it's flipping on and off very quickly. But when you take your finger off, it will either go to nothing or go brighter, and it's totally random. And the reason is because it's just whatever the last state was set in. So you're flipping on, off, on, off, on, off, on, off, on, and if it happens to be on as the last one, then it will from then on continue to be on because the switch is no longer activating the logic that turns it on and off. So you have 50%, 100%, 50%, 100%, 50%, 100%, 50%, 0. So it really is just sort of, again, it's really random. There's really no way to tell whether or not it will come on or go off. It is entirely random just because it's operating at such high speeds. So really not very useful. This is definitely not the way you would want to design switch logic to work, to have it 50% on and then randomly on and off. So I'm going to show you in the next video, we're going to kind of build some code around how you can actually design this to turn something on and off using a switch without having this sort of fuzziness to it, and also without having delays.